1. Characteristics and market power metrics. Oligopoly, few large firms each aware of the other's actions. Products may be homogeneous, steel, or differentiated automobiles. Barriers to entry are high, for example high capital patents. Firms have considerable market power but must consider rival reactions. Monopolistic competition. Many firms each selling a slightly different product, for example coffee shops, apparel. Entry and exit is relatively easy. Individual firms have limited market power because many close substitutes exist. Concentration ratios, CRK, sum of market shares of the top K firms. Example, in a market where the 4 biggest firms have shares 30%, 25%, 20%, 15%, the CR4 equals 30 plus 25 plus 20 plus 15 equals 90%. A CR4 above 60% usually signals an oligopoly. Herfindahl-Hirschman Index, HHI, sum of squared market share percentages of all firms. Using the same data plus 2 other firms with 5% each. HHI equals 30 squared plus 25 squared plus 20 squared plus 15 squared plus 5 squared plus 5 squared equals 900 plus 625 plus 400 plus 225 plus 25 plus 25 equals 2,200. An HHI above 1,800 is considered highly concentrated, United States antitrust guideline. In monopolistic competition, HHI is typically low, for example less than 500, because many firms have small shares. These metrics give a quick quantitative sense of how much market power exists in each structure. 2. Demand curves and elasticities. Oligopoly-kink demand model. Firms expect rivals to match price cuts but not price hikes. The demand curve is thus steeper, inelastic above the current price and flatter, elastic below it, creating a kink at the prevailing price. Mathematically, let P equals a minus BQ for P greater than P star, elastic part, and P equals a prime minus B prime Q for P less than P star, inelastic part, with B prime greater than B. Elasticity epsilon equals dQ over dP times P over Q. At the kink price P star, the elasticity jumps from negative 1.2, elastic, to negative 0.4, inelastic. Monopolistic competition - downward sloping perceived demand. Each firm faces a demand curve that is more elastic than a monopoly's because close substitutes exist. A common functional form is Q equals a minus BP to the epsilon, where epsilon is greater than 1, elastic. For example, if A equals 200, B equals 10, epsilon equals 2, the inverse demand is P equals the square root of 200 minus Q divided by 10. The point elasticity is epsilon equals negative P over Q times dQ over dP equals negative epsilon constant. Quantitative elasticity example. Suppose an oligopolist observes a price of $10 and sells 40 units. If a price cut to $9 raises quantity to 45, the arc elasticity is epsilon equals delta Q over Q bar divided by delta P over P bar equals 5 over 42.5 divided by negative 1 over 9.5 approximately negative 1.13. Elastic. In monopolistic competition, a firm drops price from $12 to $11 and sales rise from 30 to 38. Epsilon equals 8 over 34 divided by negative 1 over 11.5 approximately negative 2.71, showing a much higher responsiveness. Carnot competition quantity setting. Assume linear market demand, P equals a minus B times open parenthesis Q sub 1 plus Q sub 2 close parenthesis, with 2 identical firms, marginal cost C. Pi sub I equals open parenthesis a minus B times open parenthesis Q sub 1 plus Q sub 2 close parenthesis minus C close parenthesis times Q sub I. First order condition, partial pi sub I with respect to Q sub I equals a minus B times open parenthesis 2 Q sub I plus Q sub J close parenthesis minus C equals 0. Solving the simultaneous equations gives Q sub I star equals open fraction a minus C over 3B close fraction. And total output, Q star equals open fraction 2 times open parenthesis a minus C close parenthesis over 3B close fraction. Example, A equals 100, B equals 1, C equals 20. Then Q sub I star equals 80 divided by 3 equals 26.67. Total Q star equals 53.33. Price P equals 100 minus 53.33 equals 46.67. Bertrand competition price setting. Same demand but firms choose price simultaneously. With homogeneous product and identical marginal cost C, the Nash equilibrium is P equals C, price equals marginal cost, because any price above C can be undercut. Example, C equals 20, equilibrium price P equals 20, quantity determined by market demand at that price. Stackelberg leadership quantity. Leader firm 1 chooses Q sub 1 first, follower firm 2 reacts using Carnot reaction function Q sub 2 equals open fraction a minus C over 2b close fraction minus open fraction Q sub 1 over 2 close fraction. Leader maximizes pi sub 1 equals open parenthesis a minus b times open parenthesis Q sub 1 plus Q sub 2 close parenthesis minus C close parenthesis times Q sub 1, substituting Q sub 2. Result, Q sub 1 superscript SL equals open fraction a minus C over 2b close fraction. Q sub 2 superscript SL equals open fraction a minus C over 4b close fraction. Using the numeric values above, Q sub 1 superscript SL equals 40, Q sub 2 superscript SL equals 20, total Q equals 60, price P equals 40. Monopolistic competition, perceived demand maximization. Firm maximizes pi equals open parenthesis P of Q minus C close parenthesis times Q, where P of Q equals a minus B times Q to the power 1 over epsilon. First order condition. d pi over dq equals P of Q minus C plus Q times dp over dq equals 0. With P equals a minus B times Q to the power 1 over epsilon, and dp over dq equals negative B over epsilon times Q to the power open parenthesis, 1 over epsilon minus 1 close parenthesis. The condition becomes a minus BQ to the power 1 over epsilon minus C minus B over epsilon times Q to the power 1 over epsilon equals 0. Also a minus C equals BQ to the power 1 over epsilon times open parenthesis 1 plus 1 over epsilon close parenthesis. Solve for Q star equals open bracket open fraction A minus C over B times open parenthesis 1 plus 1 over epsilon close parenthesis close fraction close bracket raised to the power epsilon. Example, A equals 200, B equals 10, C equals 20, epsilon equals 2. Then Q star equals open bracket open fraction 180 over 10 times open parenthesis 1 plus 0.5 close fraction close bracket squared equals open bracket open fraction 180 over 15 close fraction close bracket squared equals 12 squared equals 144. Price P equals a minus B times square root of Q equals 200 minus 10 times 12 equals 80. These calculations illustrate how each model yields a distinct price outcome based on strategic variables. 4. Game theory applications. Payoff matrix example duopoly quantity competition. Firm A low Q20, firm B low Q20, profit A equals 400, profit B equals 400. Firm A low Q20, firm B high Q40, profit A equals 300, profit B equals 500. Firm A high Q40, firm B low Q20, profit A equals 500, profit B equals 300. Firm A high Q40, firm B high Q40, profit A equals 250, profit B equals 250. Nash equilibrium: neither firm can improve profit by changing its own quantity, while the other's quantity stays fixed. Here the low Q cell 2020 is a Nash equilibrium because moving to 40 would lower the deviator's profit. Dominant strategy: a strategy that yields higher profit regardless of the opponent's action. In the matrix above, no dominant strategy exists because each firm's best response depends on the rival's choice. Collusion, cartel, and trigger strategy. Suppose firms agree to set the Carnot optimal joint quantity Q sub C equals 53.33, price 46.67. Each receives profit pi sub C equals open parenthesis 46.67 minus 20 close parenthesis times 26.67 approximately 711. If one deviates, for example produces 40 while the other stays at 26.67, the deviator earns pi sub dev approximately 800, higher than the collusive profit. Trigger strategy: if anyone deviates, revert forever to the non-cooperative Nash equilibrium, Bertrand price equals marginal cost. The present value of staying in the cartel must exceed the one-time gain from deviation. Let discount factor delta. Collusive profit each period equals pi sub c, Nash profit equals 0, price equals cost. Condition: pi sub c greater than or equal to open parenthesis pi sub dev minus pi sub c close parenthesis divided by open parenthesis 1 minus delta close parenthesis. Solving for delta gives delta greater than or equal to open parenthesis pi sub dev minus pi sub c close parenthesis divided by pi sub dev equals open parenthesis 800 minus 711 close parenthesis divided by 800 equals 0.111. If firms are patient enough, delta greater than 0.11, the cartel can be self-enforcing. These concepts let students see how strategic interaction, not just static equations, shapes outcomes in oligopoly markets. Monopolistic competition, zero profit long run. Short run, firm faces downward sloping perceived demand, sets marginal revenue equals marginal cost, profits may be positive. Long run entry, new firms copy the successful product characteristics, shifting the original firm's demand leftward until price equals average total cost, ATC. At this point, price equals ATC and economic profit equals 0. Numerical illustration. Short run, price equals 80, average total cost equals 60, profit per unit equals $20, quantity equals 144, total profit equals $2,880. Entry of 4 identical firms reduces each firm's demand to 90 units. New price falls to $70, average total cost rises to $70 due to lower scale. Profit equals 0. Oligopoly cartel stability. Short-run collusion can raise price above competitive level, generating supranormal profits. Long-run, if entry is possible, low barriers, or if members fear punishment, cartel may break down. Example of a stable cartel: the Organization of the Petroleum Exporting Countries, OPEC, limits production. If the discount factor is high, future profits heavily valued, and detection of cheating is certain, the trigger strategy keeps the cartel intact. If a new firm can enter by paying a fixed entry cost F equals 500 and then earn perpetual profit pi equals 200 per period, the present value of entry is present value equals 200 divided by 1 minus delta. For delta equals 0.9, present value equals 2000 greater than F. Entry occurs, weakening the cartel. These dynamics explain why monopolistic competition inevitably erodes profits, whereas oligopolies can sometimes maintain them if barriers are high and firms are patient. 6. Welfare analysis. Consumer surplus, abbreviated CS, producer surplus, abbreviated PS, dead weight loss, abbreviated DWL, are measured as areas under or above the demand and supply curves. Perfect competition benchmark. Price equals marginal cost, output equals Q sub PC, consumer surplus equals area under demand above marginal cost, producer surplus equals area above marginal cost below price, which is 0 in the competitive case if marginal cost equals price. Monopolistic competition, short run. Using the earlier demand, P equals 200 minus 10 times the square root of Q, and marginal cost equals 20. Competitive output solves price equals marginal cost. 200 minus 10 times the square root of Q sub PC equals 20, which implies the square root of Q sub PC equals 18. Therefore, Q sub PC equals 324, and price P sub PC equals 20. Monopolistically competitive firm, short run, chooses Q sub MC equals 144, price P sub MC equals 80. Consumer surplus MC equals the integral from 0 to 144 of parentheses 200 minus 10 times the square root of Q close parentheses DQ minus 80 times 144, which is approximately $9,600. Consumer surplus PC equals the integral from 0 to 324 of parentheses 200 minus 10 times the square root of Q close parentheses DQ minus 20 times 324, which is approximately $13,500. Dead weight loss equals consumer surplus PC minus consumer surplus MC, which is approximately $3,900, plus any loss of producer surplus. Oligopoly Carnot examples. Competitive output. Q sub PC equals open parenthesis a minus C close parenthesis divided by B, which is open parenthesis 100 minus 20 close parenthesis divided by 1 equals 80, price equals $20. Carnot total output equals 53.33, price equals $46.67. Consumer surplus Carnot equals 1/2 times open parenthesis 80 minus 53.33 close parenthesis times open parenthesis 100 minus 46.67 close parenthesis, which is approximately 692. Consumer surplus PC equals 1/2 times 80 times open parenthesis 100 minus 20 close parenthesis equals 3,200. Deadweight loss equals 3,200 minus 692, which is approximately $2,508. Efficiency comparison. Both structures generate deadweight loss relative to perfect competition, but the source differs. Monopolistic competition's deadweight loss stems from excess price markup and underproduction caused by product differentiation. Oligopoly's deadweight loss can be larger or smaller depending on the strategic model, Carnot versus Bertrand. In Bertrand with homogeneous products, price equals marginal cost, so deadweight loss equals 0, fully efficient. The analysis helps students appreciate that not all imperfect markets are equally wasteful. 7 strategic entry barriers and contestability. Cost leadership. A firm invests in a highly efficient plant, lowering its average cost to a C low equals 15, while rivals have a C high equals 25. The low-cost firm can set a price just below 25, for example $24, and still earn profit, deterring entry because newcomers cannot profit at that price. Capacity expansion preemptive. Suppose market demand at price $30 is 200 units. An incumbent expands capacity to 180 units, leaving little room for a new entrant who would need at least 30 units to break even. The incumbent's marginal cost is $20, so the market price stays at $30, giving the incumbent a large profit and making entry unattractive. Limit pricing. The incumbent sets price low enough that a potential entrant's expected profit is negative. Formal condition. P sub L less than or equal to the fraction of a C entrant plus pi entrant star over 1, where pi entrant star equals 0 for a marginal entrant. Example: entrance a C equals $28 at the scale needed to serve 50 units. Incumbent sets $27.5, slightly below entrance. A C entrant would lose money on every unit, so entry is deterred. Contestability. Even if barriers exist, a market can be contestable if entry and exit costs are low. A potential entrance threat can force incumbents to price closer to marginal cost, the hit and run effect. Quantitatively, if the probability of entry is P and the loss from being undercut is L dollars, the incumbent's expected profit pi equals pi minus PL. If P is high enough, the incumbent will choose a lower price to reduce L. These questions test definition, recall algebraic manipulation, graphical insight, and strategic reasoning, the core competencies MBA students need for microeconomics exams. Derive the Carnot equilibrium for two firms with demand P equals 120 minus Q and constant marginal cost C equals 30. Set Q equals Q sub 1 plus Q sub 2. Profit of firm I equals open parenthesis 120 minus Q sub 1 minus Q sub 2 minus 30 close parenthesis times Q sub I. First order condition gives 90 minus 2, Q sub I minus Q sub J equals 0. Solve the system to get Q sub 1 star equals Q sub 2 star equals 30. Total Q equals 60, price equals 60. Competitive output Q sub PC equals open parenthesis 120 minus 30 close parenthesis over 1 equals 90. Price P sub PC equals 30. Consumer surplus Carnot equals 1/2 times open parenthesis 90 minus 60 close parenthesis times open parenthesis 60 minus 30 close parenthesis equals 450. Consumer surplus perfect competition equals 1/2 times 90 times 30 equals 1,350. Deadweight loss equals 900. Producer surplus equals open parenthesis price minus C close parenthesis times Q equals open parenthesis 60 minus 30 close parenthesis times 60 equals 1,800. Provide step-by-step algebra. Explain the kinked demand model and show how a small change in marginal cost does not affect the equilibrium price. Sketch demand with two slopes, elasticity above kink greater than 1, below kink less than 1. Show marginal revenue curve has a discontinuity at the kink. Because the marginal revenue curve jumps, The intersection with marginal cost, a horizontal line, remains at the same price for a range of marginal cost values. Only when marginal cost moves outside the gap does price change. Provide a numeric example. Marginal cost equals 2022-24, all intersect marginal revenue at price equals 50. A monopolistically competitive firm has demand P equals 200 minus 5Q and marginal cost equals 20. Find the short-run profit maximizing output and price, then compute the long-run equilibrium when free entry drives profit to zero. Demand P equals 200 minus 5Q, marginal cost equals 20. Marginal revenue equals 200 minus 10Q. Set marginal revenue equals marginal cost, gives 200 minus 10Q equals 20 solving, gives Q equals 18. Price equals 200 minus 5 times 18 equals 110. Profit equals open parenthesis price minus marginal cost close parenthesis times Q equals open parenthesis 110 minus 20 close parenthesis times 18 equals 1620. In the long run entry shifts, demand leftward equilibrium when price equals average total cost. Assume average total cost equals 20 plus 0.5Q. Set 200 minus 5Q equals 20 plus 0.5Q solving, gives 5.5Q equals 180Q approximately 32.7. Price approximately 36.5, zero profit because average total cost equals price. Show the adjustment paths. Using a payoff matrix, identify the Nash equilibrium and explain whether a dominant strategy exists matrix. A comma B payoffs for 4, 0, 5, 5, 0, 1, 1. Identify best responses for player A when B chooses column 1 A prefers row 2 because 5 greater than 4. When B chooses column 2 A prefers row 1 because 0 less than 1. No row dominates. For player B similar analysis. Nash equilibrium is row 2 column 1 with payoffs 5, 0 because each player is playing a best response to the other. Explain the absence of dominant strategy. Calculate the HHI for a market with 5 firms having market shares 40%, 25%, 15%, 12% and 8%. Comment on the level of concentration. HHI equals 40 squared plus 25 squared plus 15 squared plus 12 squared plus 8 squared equals 3,658. According to U.S. Department of Justice, HHI greater than 2,500 indicates a highly concentrated market, so this market is oligopolistic. A potential entrant faces a fixed entry cost of $500 and can earn $150 per year forever if it enters with a discount factor of 0.9 should it enter. Fixed entry cost equals $500. Perpetual profit equals $150 per year. Discount factor equals 0.9. Present value equals 150 divided by open parenthesis 1 minus 0.9 close parenthesis equals 1,500. Since 1,500 greater than 500 entry is profitable. Therefore, the incumbent must lower price or increase capacity to deter entry. Calculate consumer surplus in a Bertrand duopoly identical products marginal cost 10. With that in a Carnot duopoly same demand P equals 100 minus Q marginal cost 10. Bertrand price equals marginal cost equals 10 quantity equals 90 consumer surplus Bertrand equals 1/2 times 90 times open parenthesis 100 minus 10 close parenthesis equals 4,050. Carnot quantity equals 53.33 price equals 46.67 consumer surplus Carnot equals 1/2 times open parenthesis 90 minus 53.33 close parenthesis times open parenthesis 100 minus 46.67 close parenthesis equals 692. Therefore, Bertrand yields higher consumer surplus due to lower price. Explain why a cartel may be stable when firms are patient using the trigger strategy condition. Write inequality profit cart equals greater than or equal to open parenthesis profit deviate minus profit cart close parenthesis divided by open parenthesis 1 minus delta close parenthesis. Solve for delta delta greater than or equal to open parenthesis profit deviate minus profit cart close parenthesis divided by profit deviate. Show with numbers profit cart equals 500 profit deviate equals 800 delta greater than or equal to open parenthesis 800 minus 500 close parenthesis divided by 800 equals 0.375. If firms discount future profits heavily delta greater than 0.375, the threat of reverting to Nash equilibrium deters deviation, making the cartel self-enforcing.